Come on. All right. There it goes. Hey, I think we fixed it. All right, so first of all, before we do anything, we're going to talk about what we call perfect cubes. Okay, write this down. Today's date. Perfect cubes, okay? So we're looking at some number a cubed, okay? Plus or minus b cubed, okay? That's what we want to do today, is look at those kind of problems, okay? Perfect cubes. What the heck is a cube? Well, this is a cube. 8 is a perfect cube. 8 is a perfect cube because it is 2 times 2 times 2, or it's the same thing as 2 cubed, okay? Does that make sense? It's a perfect cube. 27 is a perfect cube. 27 is a perfect cube because it's 3 times 3 times 3. What's the next perfect cube? There's Hunter. What's the next perfect cube, you guys? Anybody know what's the next perfect cube? Come on, you guys. What's the next perfect cube? Oh, Emma, say 64. Oh, Emma, you are so smart. You know why it's 64? Because 4 times 4 times 4 is 64. Okay. What's the next perfect cube? There you go. You guys get 125 is the next perfect cube because it's 5 times 5 times 5. Okay. Good. And then at the same time, we'll put things like x cubed is a perfect cube. Y cubed is a perfect cube. Those are all perfect cubes, right? Does that make sense? So, here's what we need. We need 2 formulas for factor perfect cube. Before we factor this, I'm going to rewrite example 1 as a perfect cube. So I'm going to rewrite this as a 2x cubed minus 5 cubed. So I just rewrote it as a cube. Do you guys see how I got that? I know the 8 is a perfect cube. So I changed the 8 into 2x. Oh, 100, yeah, it's right there. Thank you. And I know 125 is 5 cubed because we talked about how 5 cubed, 125 is 5 cubed, okay? So we're good on that, right? Now to factor these, there's a formula. I want you to write this formula down, all right, in a different color, okay? We're going to write, we have a cubed minus b cubed factors into a minus b times a squared plus ab plus b squared. Okay, write that down. That's our formula for the day. This is our super important formula. It's really easy as long as we have this formula, okay? So write that formula down, okay? So we're going to factor. We're going to change this problem into that, okay? We really are. So let's see what we have. We have a cubed minus b cubed. Okay, I'll show it again. We have a cubed minus b cubed. So in this case, in this example, our a is going to be our 2x, and our b is going to be our 5, okay? Because we've got something cubed, 2x cubed minus something cubed, 3 cubed. Okay, how am I doing? Am I doing okay? So then since I know a is 2x and b is 5, I just plug it in the formula. I'm going to put 2x here, 2x squared, 2x, and I'm going to put my 5 here, my 5 here, and 5 here. Okay, so I'm going to write this answer as a minus b, or 2x minus 5, okay? A minus b, or 2x minus 5, times a squared. All right, what's this squared? What is this squared? What's this squared? Isn't that 4x squared? You guys agree with that? Plus AB. AB means a times b, which is a 10x, plus b squared, which is 5 squared plus 25. And that's it. We're done. That's the answer. Okay. Okay, let's look at example 2. Now, example 2 is different. Example 2 is what we did last night. Okay? Example 2 is what we did last night. So, on example 2, do you guys see anything? Anybody see anything? Well, don't they all have an x in common? Right? How many x's do they all have in common? At least. Right, so let's take out the 1x. I'll have an x squared plus an x minus 2. Okay, to make this easier, I'll put a 1 right there, okay? Okay, this can be factored again. I'm going to leave the x out, but this can be factored again. So, easy question, okay? Olin, what times what makes 2? What times what makes 2? What times what makes 2? Yeah, 2 and 1, right? So how about an x plus 2, x minus 1? Done. Boom. Done, right? And you know where the positive 1 comes from when you multiply. Okay, right? Done. Boom. Easy. Okay? Let me go ahead and circle. That's my answer. There's my answer. All right? Number 3. Oh. So they don't have anything in common, do they? They have nothing in common. But how am I going to make an x to the 4th? How about x squared, x squared? You okay with that? X squared, x squared? So we go like this. And let's start out with x squared, x squared. I do that, okay? All right, Emma, easy. What times what makes 4? What times what makes 4? 2 and 2, good. Let's use the other one, though. Let's use what? What times what makes 4? Yeah, well, because 1 and 4 would make a 5, wouldn't it? And how about a -1 and a -4? I'm okay with that, because that would multiply to make the positive 4, but add to make the -5. Nice job. Now, both of these can be factored again. This can factor into an x plus 1, x minus 1. Okay? And this is going to be factored into a x plus 2, x minus 2. Okay? How's that? So all of these factorings today require us to factor everything twice. It's not like geometry, just factor it. This is like Algebra 2 where you got to factor everything twice. Okay? How's that? This is very similar to what you'd see in a college algebra class, okay? Which is good because I want to get you ready. If you're going to go to college, I want to get you ready anyway, right? Okay, number 4. I see 4 terms, right? So A to C, what are we going to do? You said it last time. What are we going to do? We're going to group it. So if I group these two, okay, what do these two, first two, do they have anything in common? Of course they do. Hunter, what do they have in common, first two? Yeah, they've got x squared in common. They've got at least 2 x's in common. Totally agree. So if I take out 2 of the x's, I'll have an x minus 2, okay? Now the second group's a little bit different because they don't really have anything in common, right? But I want to make it look like this. So I'm going to take out a -1. It's a little tricky, but if I take out a -1, then it changes their sign. So if I take out its negative, it'll become positive. If I take out a negative, it becomes negative, right? So I'm going to have an x minus 2. And if that doesn't make sense, just go ahead and multiply it back through. Okay, just go that times that, and that times that. That makes the -x, and that makes the positive, okay? Now, we're where we want to be, because we've got these two things are the same, right? So then the next question is, what do they have in common? Well, what they have in common is the parentheses x minus 2, right? So I take that out. And then what's left over is the x squared minus 1. Oh, wait a minute, we can do that again. In fact, we just did the same thing. We did that up here, right? Did we just do that up here? So we do that part again, because we just did it up here for the exact same way. So I see that x squared minus 1 can be a x times x plus 1 minus 1, okay? How am I doing? Right, page. Okay, example 5. Kaylin, what do you see? Do you see anything? Yeah. There's a multiple of 2, right? And they both have at least x to the 6th in common. So let's just, if I take all of those x's out, it should make it easier, shouldn't it? Right? Should make it easier. So we should get a x cubed minus 8. Wait a minute. I think it's that one right there. It's that one right there, right? Same formula, right? Let me write it so you guys can see it, okay? So I'm going to rewrite up here so we have it. If I have an a cubed minus b cubed, so then this is like an x cubed minus a 2 cubed, right? That number is 2 cubed. So, and we just wrote the formula down on the front of this page as a minus b, a squared plus ab plus b squared, right? And ignoring this 2x to the 6, okay? I know in this example I'm going to let a equal x, or because x cubed, and I'll let b equal 2. That's a little bit harder, isn't it? So really have an x cubed minus a 2 cubed, x cubed minus a 2 cubed. So let's plug this into the formula. So I'm going to go, okay, I'm going to take my x's and plug my x's in for a. My b's will be 2. So I'm going to rewrite this as a minus b, x minus 2 times a squared. Well, a squared is going to be my x squared plus ab. Well, ab is plus 2x plus b squared is 4. The last thing I got to do is I got to remember I actually have this part of my problem too. All right, I got to remember to bring this back in. So make sure I get that in there. So I'm going to have an answer of 2x to the 6th, x minus 2, x squared plus 2x plus 4. Okay, how's that? These are hard, aren't they? Okay. Example 6. Oh, that looks like a pretty ugly problem. Can we make it better? Can we make it better? Who haven't I picked on for a while? Let's see. Jose, what do you see?
I'll have contact to the 4th.
Yes, so let's take out at least x to the 4th. I totally agree. And I'm also going to take out a 2. You okay with the 2 also? So I'm going to take out a 2 and x to the 4th. Nice job. That x to the 4th, getting rid of that x to the 4th is really going to make this easier. You agree? Nice job. So that's going to make an x squared minus a 13x plus a 42. Okay. It's getting easier. It is. All right. Olin, what times what makes 42? Yeah, 21 over 2 is right, but let's use a different number, okay? Because that won't make a 13. You're right. What's the different combination? Yeah, 7 and 6 will make it 13, won't they? So I'm going to go x minus 7, x minus 6, because that will multiply to make my 42, but it'll also add up to make my negative 13. Okay, now there's one more I want to give you before we do the last one, okay? One more I want to give you, okay? We've got this a cubed minus b cubed, right? We've got this a cubed minus b cubed, right? So I also want to add in your notes, let's add this. Let's add this over here. A cubed plus b cubed. The only difference is the positive negative, okay? This one factors into an a plus b, a squared minus ab plus b squared, okay? Almost identical formula. Almost identical formula. The difference is, only difference is there. And the signs are different, okay? I meant to put that on this sheet, but I forgot. Okay, write that down. So these are the two we're going to use today, okay? All right, slide it up. Okay, now, number 7, determine if this is a factor, okay? So So we looked at this one like this one yesterday. I want to do it again, okay? So 1 I could divide. I could divide, right? And find out if I get a remainder of 0. I could do that. I could do the synthetic division. I'm not going to do this, by the way. I could go -1 into 1, 0, -13, -12, right? I could do that. And I could look for my remainder. That will work. And if I get a remainder of 0, I've done it, okay? But we also talked about this thing called synthetic substitution. So if I plug in x equals -1, it's faster. Does that make sense? It's faster. Both of these will work. Divide it, get a remainder of 0, boom. Or if I plug in -1 and get an answer of -1, it also works. So let's plug in -1, it's faster. So I'm going to go -1 cubed, so plug it in, right? -1 cubed minus 13 times -1 minus 12. I like my calculator. It does work for me. Don't call me lazy. Just call me smart because I use my calculator, right? I can actually do this in my head, but I won't. Just to prove to you. What do I get? I get 0. So because I get an answer of 0, it's called synthetic substitution. I get an answer of 0, then it is a factor. Okay? So you get an answer of 0, it's a factor, which means it goes in even. If we were to divide, we'd get an answer of 0. If it goes in evenly, no remainder, it's a factor, right? Okay. That's all I have, and we got